One of the things I miss the most about other languages when I work in JavaScript is the fact that classes and functions or methods in classes can't be overloaded, which means you can't write multiple implementations of the same method or function, and just sort of based on the arguments, the types of the arguments that you have and the signature of the function, you can't write a different implementation. And sometimes you really want to do that, especially if your class is encapsulating a behavior and really modeling something specific. And so what we're going to do today is we're going to add that ability to JavaScript in the form of a library, in the form of a runtime library, which of course will come with some performance cost and will come with some it won't be able to use, the standard keywords and that kind of thing. It won't be able to use the class keyword directly because it's a runtime abstraction. But I think there is quite a lot of benefit to doing this, and I have an idea about how to do it already, and I think it will make for quite an interesting video, and that's why I'm recording this now rather than just writing it and releasing it. Okay, so just before we get into it, it's good to mention that the reason JavaScript can't have overloadable methods and overloadable functions just sort of out of the gate is because JavaScript is a dynamically and weakly typed language, and therefore there will be no way of looking at a function signature or a method signature that you've defined in JavaScript, even if you've defined multiple and they take different kinds of arguments, maybe they have different names. There will be no way of determining which version of that function or method you should dispatch to, because you don't have the types around to tell you, oh, okay, you gave us an integer and a string, and therefore I'm going to call this version of the function. Or in this time you gave a string, only a string, and therefore I'll call this version. And there's another thing that people often also bring up, and it's not a barrier in this case. In this case, it's actually going to allow us to do this. But JavaScript doesn't have real classes because JavaScript is not a sort of typical object-oriented language. It's actually based on a prototypical system of inheritance. And what that means, it's kind of not in the scope of this video to really get into how the prototype system works and differs from regular classes. But essentially, it's more of a compositional model than regular classes, and classes can borrow each other's methods and use them as if they were. And you don't have to really have multiple instances of a given method or function in memory at a time. It also means that things can be a function and a method at the same time, depending on how you use them. But it is a cause of confusion, and some people really are really turned off from JavaScript simply because it can be kind of confusing to know what this keyword means in certain contexts. Although once you understand and once you've learned what's going on there and the ways to avoid the difficulties, it's not really a problem, especially in the later versions of JavaScript, which have provided things like arrow functions, which allow you to retain the sort of context that you define that function in, and therefore it becomes a lot easier. Okay, so the class keyword was introduced in 2015 in ES6, and before that there were no classes, and there was no class keyword, and you actually had to define class objects in a different way. And we're going to see how that works. Let's get into it now. I've prepared an empty repository here, and I've called it Classiest because I thought that was a nice name. Actually, I wanted to call it Classier, but I found out that on NPM there's already a library called Classier, and it was actually to add sort of class-like behavior to JavaScript before the class keyword was introduced. And so I've gone with Classiest. There's no code in here right now, and the package JSON is empty. And yeah, let's actually just get started. So let's just illustrate the problem first. Let's say I have a class which is a vector3. So imagine this class is representing something like a point, like a 3D point, and it will have all kinds of operations, like you can add two vectors together, and well, let's just write the constructor first, imagining it will take x, y, and z, and we'll assign those to internal properties, and we'll have our x, our y, and our z. And then you can imagine that you might want to have a method like add, where you can add another vector, and we might do something like this, where we return a new vector3, and its x, y, and z are this.x plus b.x, and then this.y plus b.y, and this.z plus b.z. And this is an immutable class, so we're just returning new versions of vectors instead of just altering the one in memory. Yeah, so then we've got this add method, and that's nice. But maybe there's another valid implementation of add. Maybe there's another really useful valid implementation of add, and there is. And this actually is the reason that I started writing this, because I've been working with 3D vectors for something in an upcoming project, and I just realized that how annoying it is to not have these kind of method overloads. So what we might also want to do is just add just a number to the vector, and what that would mean is that instead of adding, three individual components of another vector, instead what we would do is just add the same number to all three components of a vector. And yeah, that can be really useful in some places. Yeah, this is kind of the crux of the problem. We could also imagine that we might want to write multiple constructors. So we might want to have a constructor where we have x, y, and z, but we might, again, want to have one where we just give one number and we assign all the components to that. Yeah, so this is kind of the core of the problem, and this just isn't possible now. And what, at the first glance at this problem, what you might think is, okay, well, we can look at the number of arguments you get to a function, and JavaScript does give you that. So if you define a function with a fixed number of arguments, it will tell you, like, you can introspect its length property, and you can find out, okay, there's this many arguments in this function. But you can always give it more, or you can give it less, because it's dynamically weakly typed. It doesn't care if you just don't give it one of the arguments. And so there isn't really any way of doing that. But you might think at first, okay, maybe I can just look at the number of arguments and I can dynamically dispatch based on the number of arguments. But that won't work in cases like this, where in this case we have one argument, which is a vector. In this case we have one argument, which is a number. So that's kind of the core of the problem. And the way we're going to solve this is by coming up with a kind of API where we can do something like this instead. So instead, this time we'll create a vector3, and we'll call this yet to be written function classiest. And then we'll maybe give it a name, and then we can give it some kind of object where we're going to define its methods. And actually, I think what I want to do is I want to have an object where you can do things like, where there would be one key for methods, and there would be one key for static. So you could write static methods that could also be overloaded. Maybe there's even a constructors section or something. But for now, just for the very, very first initial prototype of this, what I think I want to do is just have something like this. So we have an object, it's got a key constructor, and you can actually use this syntax in the later versions of JavaScript. But what I'm actually going to do is this. I'm just going to say that we could provide functions just like this. So this is a loose function, but if you call this as a constructor, that would totally be valid, and we could assign properties to it. to the instance. Okay, so this is one thing we could do, but of course we might want to have multiple constructors, and so what we might want to do is create an array instead. So something like this, and then we would take our function definition here and cut it out, and you can imagine we would put it in here, and then maybe we would have another one where we've got this end property where we're just assigning to everything, and we would do something like this. But again, for reasons that I've been over, this won't work because we still have no way of like looking at those properties, looking at those arguments, and understanding like what we're supposed to give here. And that's where like a runtime type system is going to come into play. And so I'm going to use a library called TCOM, which is very well established. It's actually no longer maintained, but it is pretty much complete. So it's not really in need of further development. And there are other options. There are other libraries that do the same kind of thing that are still maintained. But I think for this precise use case, and being the fact that I want to keep this type system very well defined and very much within the library, and not leaking outside of it too much, and not getting into the gritty details of certain things like that, I think that will be fine for now. But again, this is the first prototype, so I might change that at a later time. But for now, let's just npm install TCOM. And TCOM has a kind of a sort of sister library called TCOM validate. I think it's called validate. Maybe it's called TCOM validation. Yeah, I think it is. And with TCOM validation, what you can do is you can kind of define your type model in one place, and you can use validate in a sort of a more efficient way. I believe that it uses some different ways of assessing if types are correct, and also some looser ways of assessing if types are correct in terms of how it does its comparisons. So we're going to use that. And I've made these dependencies of this library, and that's what you might want to do. I mean, this is kind of in the weeds a bit, but if you've developed libraries and you make libraries in JavaScript, there's this concept of something called a peer dependency. And there is this concept in many languages with different names. But basically what peer dependencies are just bits of code that you expect the user to have in the project. So it's one of their dependencies, and you simply depend on whatever version of that library that the user also depends on. Well, you can specify the version, you can specify a range of versions, but you kind of make it not part of your package. You say that the user has to come along with that. And there are plenty of good reasons for doing this, especially if your library works with some other library and you kind of want to be agnostic to its own versioning. But that's not for now. I'm just gonna include TCOM into this project, because I think, well, I've done the trade-off analysis in my head, and I just think it's the more useful use case. And I'm actually going to also probably expose the TCOM object through the library, because the user will be able to create their own types as well and use them for this. So that's kind of the the initial part here. So actually, let's just delete this vector3 class. We can always write that again, and let's bring in TCOM. We'll just call it T. That's the typical way of doing it. And from TCOM validation, we want to bring in the validate method, although I think maybe I spelled this wrong. Well, let's just double check that now. Make sure both of those are properly defined. Can't find module TCOM validation. Yeah, well, that makes sense. Okay, and it's found that now, so we're all good. So what do we need to do here? We need to obviously define this this classiest function, and yeah, there's actually going to be a bit more to this. This object is not going to be enough on its own. I already know that. we're going to need to provide a function here. But we'll get to that. We'll get to that when we come to it. So const classiest, that's going to be our function. We're going to take a name, and we're going to take, I'm going to call it a descriptor function. Well, it's going to be a function, so, but it will return a descriptor object. Yeah, and so how's this going to work? So, oh yeah, I actually didn't finish describing how this will be done. So we're going to use TCOM, and what we're going to do is, instead of just sort of putting loose functions in this array, what we're actually going to do is provide objects. And the object is going to describe both the arguments, basically the signature of the function, and the function itself. So we'll create a key called args, which will have, which will be an array. And to this, we will pass TCOM types. And TCOM has a bunch of built-in types for things like, you know, number and string and Boolean and regular expression, and probably some others. I think it's missing some. Well, you can actually see what it has here. It has date, error, function, integer. So TCOM is actually, because it's a runtime type system, it's actually really nice. It's a sort of dependent type system as well. So you can, you know, you can express that not only must something be a number, there's only a number type in JavaScript, there's no integer, but it must be an integer as well. And you can do that because you can also sort of further refine your types through predicates and yeah, and other kinds of operations that you can do with other types. And it's really interesting, and you can go very far with it. I think usually it's better to be as simple as possible with these kind of approaches. It's very easy to overcomplicate things. So we've got all of the standard types here. So let's just say, you know, this one takes 3 numbers. So it will be t.number. And the implementation, we'll put it under a key called fn. And then this is the implementation. And so this would be how we could define, this could be one sort of overload of the constructor. And then maybe we have another one, and this one just has the one number. We'll call it n or m. And yeah, so that's that. And let's also, just while we're here, let's also put in this add function. And it's exactly the same. I'm even going to just copy this. Now, we could add one number to it. So that would just be the case where we have n. I should have just taken this one. Then we need to return a new instance of something. And, well, I think we could just return, you know, a new instance of vector3, and we're referring to it here. And this will work because of just the way that the scoping rules of JavaScript work. It won't evaluate what vector3 is. So if we put this here, even though we're kind of like using vector3 within the definition of vector3, this won't be evaluated until we actually go to use it. But what I'm actually going to do is I'm going to make this a function, and it's going to pass us both the class and a TCOM representation of its type. And that's just a nice way that we don't have to worry too much about the recursion of the whole thing. And we don't have to worry about sort of figuring out how to make a TCOM type out of the class. So yeah, so we'll just call this v3 and then iv3. So for an instance of the v3 for use in the type system. Maybe there's better naming convention than that, but okay. So then I can wrap the whole thing in brackets. And now what we've got is a function that's taking 2 arguments and returning an object, sort of in an expression form. And this is enough. And so now we can return a new v3 instead, and we could use any of its constructors, but in this case we're going to use its first constructor with 3 arguments, and we're just going to say this.x plus n, and then this.y plus n, and this.z. that's that. And then, of course, we've got the second version of the function where we don't have a number, but instead we've got our IV3, which is our instance of, our type instance of v3. Maybe that is better named sort of v3 type. I don't know. Not there with the standard naming scheme yet. Okay, so now we've got our implementations. Have I missed something here because this is turned blue? Function. Well, maybe I've done something wrong. We'll find out when we get to that. But at this point, this should be okay. There shouldn't be any problems with that. So let's just see it runs successfully. Okay, so we're going to take our descriptor function, and this is the descriptor function. And one of the things I think will be really useful is to just write a TCOM model of how the classiest definition works. And that will allow us to also understand how TCOM is working for the purposes of this. So I'm going to put all of these types just into something called D for domain. This is the domain of classiest. This is just a convention. This is maybe not the best way of doing something, but it's we'll just go with it for now. So I'm going to create. Well, the great thing about these types, they're kind of like combinators, and you can first start with your sort of atomic level types and sort of build them up and up and up. And if you've seen my series on parser combinators, it's that same kind of composition model of sort of starting with a small thing and building it up until you have more complex descriptions. It's actually exactly the same in many ways. Okay, so let's start out with defining this object. Or rather, actually, let's start out defining the complicated thing inside, which is this argument array. So this will be arg array, and we'll make that with a t.list, so a list of something, and we need to give it a type constructor here. And this is going to be the special type, which is t.type. How is it? I think it's just t.type. I'm gonna just validate that. Could look at the docs, but this will work just as well. Yeah, t.type. I'm not quite sure why that doesn't appear in the IntelliSense, but and t.type is like the self-referential. This is a TCOM type, so it's a really useful one if you're writing this kind of meta program with a type system. Okay, so that's the arg array. It just takes a list of t types. Then the next kind of thing up is this whole object itself. So this will be, let's call this an overload description. And this is an object. We can actually call it TCOM has two ways of sort of defining objects. It has structs, but it also has interfaces. And if I understand the definition correctly, the structs are, they have some special comparison rules which have to do with instance of, because these TCOM types that you create, they also become constructors themselves. And the library kind of mixes together the idea of creating constructors and type checking, and it allows you to turn off the type checking in production environments so as to not incur a runtime cost or a minimal runtime cost. We're not going to be using any of the constructor stuff, and we certainly want the simplest, most structural forms of comparison when it comes to how we look at these objects. So I'm just going to use an interface, and so we know that we've got two keys here. We've got args, and that's actually going to be a d.arg array, and we're going to have an fn, and that is just going to be a t.function. So that's just a regular JavaScript function. So okay, we have this now, and so d.overloads. So that's when you've got a method or overload. That's just going to be a t.list of d overload descriptions. Now I mentioned that I want to just, because you don't always want to have multiple functions, I also want to have the ability to define a one-time function. So for instance, if we wanted to make for a vector, we wanted to make like the length method where we get the length or the magnitude of the vector, then we really just want to write a single function and return this.x squared plus this.y squared plus this.z squared, and we take the square root of that. We're dealing with Euclidean distance here, so we're just using Pythagoras kind of equation, and then yeah, so there's one length. Actually, there's many different length metrics you could use, but in this case, we'll leave the regular length metric. There's only really one valid implementation of that. So I also want to allow the possibility of just having a function. So a D method definition, or let's call it a D, let's just call it a method, is either it's either going to be a set of overloads, or it's going to be just a regular function. And we have unions in here in TCOM, and that will allow us to basically create a set of types. So we're going to have either a t.function or a d.overloads. Okay, and then this whole object is going to be just sort of a dictionary type of string names to methods. So the d.definition is going to be a t not how is it called in this? It's not a, it is a dictionary, yeah, dict. And so a dictionary of the constructor of string and code emit. So I think here we can just say t.string and d method. I think this is valid. And then yeah, we can just check this out by sort of putting this first check here. And so validity result is going to be the validate from TCOM validation. We're going to pass our description function. Yeah, and so we need to actually provide some data to this description function, but for now, I'm just going to get the description from the, or we'll call it the descriptor. And we'll pass in those in a second, and we're just going to validate this. So we're going to validate the descriptor against the d.definition model. And then here we can take a look at the validity result and make sure everything is okay. So we got an error, so I did something wrong. And the error is invalid value args. Well, it's maybe easier to look here. Validity results dot first error. I should maybe throw this. Well, errors 0. And that is itself a structure. And what do we have inside? Errors 0 message. I just want to see the message in a form that is readable. Invalid value, so the whole thing supplied to function add. Okay, so add. We did something wrong. Oh yeah, because that actually does make sense. So we're saying this is a TCOM type. So let's just pass null and then t.string here, so that we have given it a TCOM type in that place. Okay, and now there are 0 errors. So this is maybe okay so far. Good. That actually proves that this works. So what we can do here is we can say the validity result. If the validity result is error or is valid, so we have to invert the condition. If it's valid, if it's not valid, then we're just going to throw new error. And what we can do is we can say validity result.first error, and that's the one we'll throw. If there are multiple errors, we'll allow the user to fix them in one after the other, and just keep getting a new error every time. Okay, at this point, they've successfully gotten their description through the pipeline, and we can start building the actual class with our special dynamic dispatch. Maybe before we do that, let's actually address this problem where we're not passing the things we're talking about passing it. So let's say that the constructor, CSTR, is going to be a function I'm going to do this as well. I'm going to say dynamic constructor. This is really going to be a little bit of a weird thing here. Okay, so what we're doing is we're going to make the constructor, and then we're going to create this function, and then what the constructor is going to do is going to call something called dynamic constructor, and that is a yet to be written function that will, based on the description, dynamically dispatch to the right constructor. And again, because of this thing that I mentioned earlier, this won't be evaluated until JavaScript actually runs this function, and so we're safe to call it here, even though it hasn't yet been defined, because we know we will define it. It's going to become defined by the time it's called. So that's fine. And what it means is that this function, even though it's calling some dynamic function, which is going to change, this function won't change. And so this is the constructor. And so we can pass this constructor here as the constructor that will be called. And the type of this constructor, well, the type of this is going to be like an instance of the class. And TCOM doesn't, I don't think it has just by like a built-in thing for that. So I'm going to write like a helper here called instance, and it will take a class. I won't call it class because that's a keyword. We'll call it C, and that's going to be a T refinement. And so a refinement is just a predicate-based type. So it will simply run a function to determine whether this thing is a valid kind of constructor. So we're going to refine, we have to refine something. I guess we can refine t.any, and so that's just any type. That's just like always true. We'll just refine t.any and we'll say is like x, the thing we got, the thing that was supplied supposedly as an instance. We can say x is an instance of C. And so that puts the sort of standard way of checking if something is an instance of something, like a regular class, like our vector class, if that the thing that we got passed if it is an instance of that. And that turns that into a TCOM type. So now we can give we can do this. We can basically say, is the thing we got an instance of the constructor? Cool. And what we can also do is we can give the constructor a name property, and that will just be name. And that's just kind of useful to do. That will help with error messages and debugging, stuff like that. Okay, so that's kind of taken care of. We can actually get our thing here, and if we run this again, we should see that it works. It does work. We didn't throw this error, so we successfully passed an instance of this thing, and now we need to do the dynamic dispatch part. Okay, so how is that going to work? We've got this description object, and what we're going to do is what we need to do is we need to iterate through this description object. So let's do that first. I'm going to create a function here. That's not how you create functions. I'm going to call it dynamic dispatch. Dynamic dispatch. It's going to be a function, and it's going to take some stuff. We're going to define it in a minute, but just so it's there. And what we can do is we can say for let method name method implementation. Let's call it method impl of object.entries descriptor. So for all the keys and values in our descriptor, we're going to treat one as a method name and one as a method implementation. We already know that the format is correct because we've type checked it, and we're just going to go through it and say, okay, in the first case, if method implementation is an instance, no, not instance of, we want to do type of method implementation is function. So if this is a function, this is just like a regular function. This is fine. We can just call this any way we want. So we can just put this on the constructor, just like this. Method name equals method import. Cool. And if you haven't done much JavaScript, this is where it maybe starts to look a bit weird, because we've got a function up here called constructor, and we've started to do things like put a name property on it and just assign key values to it. And yeah, this works in JavaScript, and this is sort of the root of how things work. This is actually not true. In order to put the methods on there in the proper way, we need to do prototype method. And so when you have a function, a constructor function, or any function, it has a prototype. And when you put stuff on the prototype, that's like giving it its methods. And now you can start to see that actually what we have here is well, in constructor it's not the case, but here on length, we've got like a loose function. We could put this function in a variable and just assign the variable here, and then also make that variable a method on our constructor or on our class. And all of those are the same instance of a function, just doing different things. Oh, well, not even doing different things. It's the same instance with the same code, but potentially running in a different context with a different this. And that's kind of the key. It's kind of weird to wrap your head around, but you can maybe get a glimpse that this allows for composition and for code reuse in a way that a lot of languages don't. It's pretty cool, I think. One thing I forgot to do up front is we have to treat the constructor a bit differently because of this stuff that's going on up here. We need to actually we're going to have dynamic dispatch, and dynamic dispatch will be used by dynamic constructor. But for the moment we have to keep them separate. So what we actually want to also do is just make sure that the method name we're dealing with isn't constructor. Or if it is constructor, then we're just going to continue, right? we'll go to the top of the loop again, because we're going to handle that separately, but pretty much in the same way. Okay, so if it's a function, easy, we do that. If it's not a function, then we know it must be our like special description, right? Our overloads. And so this becomes a bit more interesting. This becomes where we're going to dynamically dispatch to it. So we can say that this .prototype.method name is equal to a function that we'll define right here. And that function is going to take some set of arguments. And in JavaScript, you can actually just sort of capture all the possible variadic arguments like this with the spread operator. I'll just call it, I'll call it, let's call it method args. Don't know if that's the best name, but it's the one we'll go with for now. And what we're going to do here is we're going to return a call to dynamic dispatch. And we're going to have to do a few things here. We're going to have to supply the name, so that will be the method name. We're going to have to supply the set of implementations. So that will be method impl. And we're going to need to supply the arguments, of course. And we can just, again, spread those out. So that will be method args. Is that everything? I think, well, we'll see if that's not everything in a minute. And you can see that we're just returning it. So like whatever we get back from dynamic dispatch is just going to be the return value of this function. Cool. So then we've looped through everything. We've built up these kind of function representations. We haven't written this yet, so that won't work. And then at the end, we're going to return the constructor that we've built up. So that's how we end up getting an actual constructor at the end. Okay, so let's now implement this this function. Okay, so when we do dynamic dispatch, we've been given a set of arguments. And again, these have been captured up in an array. This is an array now. They get sort of collected up into a nice array for us. And we need to go through all the method implementations. I guess we can call this method impulse because we know it's multiple implementations. So let's basically loop through until we find one that matches. And if we don't find one that matches, we'll throw an error. And that's pretty much it. So implementations are just objects which have args and a function. So we can say for let args function of method impulse. And if you haven't used a lot of JavaScript, then yeah, this kind of syntax allows us to just pull those variables out, to destruct them out of the object and have them in these names. Yeah, so we're looping through, and what we actually want to do is we want to make sure that every single one of the TCOM types matches what we've been given as a method argument. And the way we can do that is we can say, well, let's say we'll create a variable called matches. And what we'll do is we will say args.every, so we're going to loop over every argument and assert that a predicate is true. So we're going to supply a predicate function to this, so that's going to give us an arg. And we're going to say const, well, I'm just going to call this vResult this time instead of validity result, so we don't shadow names. We're going to validate, and we're going to validate the thing at the same index. And one of the nice things about JavaScript being loose with its types is that we can like look into an array with an index that may be out of bounds, and we'll just get undefined back. And in this case, that's great, because if it's not defined and TCOM doesn't allow it to not be not defined, then that won't be valid, and that just works out perfectly for us. So what we want to do is we want to look into method args at index I and compare it with this arg, and let's call it type arg, so it's a bit clearer what that is. And maybe let's call it type args. No, but that will imply that we need to destructure it. It seems that I've stopped moving here. Not quite sure what's happening there, but that seems to happen every now and again with QuickTime. All right, doesn't matter. So if not matches, well, okay, we're not quite done here, of course, because we've got the result, and here's where we need to check the result. So if the result is valid, that's the only thing we care about. Actually, we can just return result is valid. We don't need any other information from that. And I guess that means we don't need to make an intermediate variable either. So let's just return this, and then we can take away this and just return an expression instead. Still spread it on 2 lines, because then it's a little bit easier to read. So if it matches, well, if we found a match, let's do it like this. If we didn't find a match, let's throw an error, and we will throw the error, which is no valid implementation, no valid overload found for, and let's do like this, name, so that's the name of the class, dot method name. It's not the best error message in the world, but will do for now. And wait, is this correct here? So what we're trying to do is we're checking if this matches. Oh no, that's not true. So if it does match, then we want to do something. But if it doesn't, then basically we want this piece of code to be at the end, and we don't want to make it conditional. So it's basically if the code reaches this point, then we're throwing the error. But if it matches, then we can just return a dynamic call. And so to get to that dynamic call, we need to go to the descriptor. Then the descriptor object, of course, it has these keys and values. So the key is method name, and then we have a set of, what am I doing? We've just got the function here, of course. So we can just return the function, and we want to return the function, and this is something that I've forgotten to do a bit further down. What we do it here, we want to return the function applied. So this is where it's also going to get a bit weird. So we're going to apply it with this as the context. So whatever the context of this function, dynamic dispatch, is, that's going to be the context that we continue with. And the arguments that we're going to supply here are going to be method args. And apply takes sort of a context and just an array of arguments. So this is the perfect signature for this. Okay, so that means that when we call dynamic dispatch, we need to do the same thing. So here we need to apply a call to this, and we'll supply this as the first argument. And that's, see, we've got an arg array, and this isn't an array, of course. What we actually want to do is use call, which is the same thing, but instead of having an arg array, it's not a real arg array. Maybe we can see it better if I highlight that here. we can see that call has a spread out arg array. So that basically means that just all of the arguments come in one big line like this. So, but the main important thing to note here is that this is going to be called with this, and this is going to be part of the constructor now. So we have our class instance here, constructor, we're putting a method on it, and then this function is something that will be called. And so long as this is called within the bounds of how a method should be called with its context still attached, we can pass that context along, and this dynamic dispatch function that we have can become basically a sort of surrogate method, as it were. Great. Okay, so that is how it works for the methods, and now we need to deal with a constructor. And so here we've got this dynamic constructor thing, and basically we need to assign that. And let's just put it down here just below dynamic dispatch. So dynamic constructor is going to be a very similar kind of function, where it's going to have, well, it's not going to have a method name because that's just the constructor. So it's going to have some arguments. So we're going to put those up here. I'm going to call this CTSR arguments, constructor arguments, and here we're going to do the same thing where we apply our dynamic constructor, which is this, and our constructor arguments. And we don't return this because it's a constructor. Constructors shouldn't return things. They should just do side effects, basically, and assign properties. Okay, we don't need method implementations because we know that there will be only one name, and we can take a look and we can see that there is either a function or there is a thing. It'll basically be like this. So let's just copy this as the basis. So in the case that descriptor.constructor, the type of that is a function. Well, if there's no constructor, let's just early return. So if not constructor in descriptor, we're just going to return. Because there's nothing to do. If there is, then we want to check, is it a function? In that case, at this point we need to call that function, right? So we want to simply call that with the method arguments. So we're going to constructor.apply. And no, we don't have to apply yet because we don't have a context. No, that's not true. We do have a context, of course. So I want to apply this with method args. And if we don't, that means that we have constructor instances, and then we're going to use dynamic dispatch to do this. So we will call dynamic dispatch with this as our context. Our method name is going to be constructor. Our method import is going to be descriptor.constructor, and we have method args. And I think that should be it. I'm sure I've made an error because I've been typing code now for about 70 lines. So let's try this out. Let's see if we can get to this point. But let's fix the errors that come up first. We actually got here. That's kind of unexpected. Then again, we haven't tried to instantiate this yet. Oh, the name is CTSR, so that's not quite right. I thought we could assign here the name. Maybe we have to put the name on the prototype. I'm not sure. Anyway, that's the next thing we can tackle. Okay, so let's create some instances of this class. That's sort of the test. So v0 or v1 be a new vector3, and we don't get nice auto-completion here. That's just part of the deal. We don't have that. But we have two possible constructors. We have one where we can supply one number and one where we can supply 3. So let's do that first. Let's do 1, 2, 3. And then we will want to have a second constructor where we just have 1. So that we'll make that 4. Let's see if that works. v1, 1, 2, 3. v2, 4, 4, 4. Okay, that actually seemed to work. Can we do operations on these vectors? So if I try to create v3, which will be the result of v1.add v2, we should get something, and then we'll make v4, which will be v1.add, and then we'll just add, we'll add 2 to everything here. And we define one more method, which was just a regular function, so we would expect that to work fine. So that's going to be the v length, and we'll just do the length of v1, so v1 length. Let's run that again. No errors. So v3 is undefined. Okay, so something went wrong there. So we tried to add v1 and v2, and somehow got undefined. Also undefined for the other call, but we did get the length, it looks like. Yeah. Okay, so let's have a look at how we might fix whatever went wrong with add. So let's take a look here. We didn't get an error. We didn't get an error that this couldn't work. Let's put some breakpoints in. Put a breakpoint there. Well, this one makes sense. I understand why we didn't get this one. Return new v3. And here we just return the v3, and that's not valid. So I think I actually see how this didn't work. All right, so instead of equals, there'll be pluses, and there'll be commas. Oh. Okay, that's that error fixed, and this one, well, we didn't make a new instance of it, and that is why we didn't construct something. So let's try again. All right, so we get 5, 6, 7 because we added 1, 1, 1, which is oh, that's not quite right. Okay, so we've got, no, that is right. That is right. We got 5, 6, 7, of course. Okay, and with v4 we got 3, 4, 5 because we added 2 to each of those. Well, this is great. This is actually working perfectly. Somehow, first time, more or less. Well, this is kind of the core of it, actually, and I want to do some more with this. I want to, using exactly the same principles, allow for static methods. But yeah, I think this is pretty much the first version is there. So I'm going to, before I release this video, I'm going to push an initial version of Classiest to NPM, so no one takes that name. And yeah, need to write some tests and things like that. And I think there are probably some features that maybe are useful that I haven't thought of now. So I'll also put a link to the GitHub repository in this video, in the description of this video. And if you have an idea of something that could be an interesting feature and wouldn't introduce too much complexity, then you can open an issue and we'll discuss it. And feel free to make a pull request if there are existing issues that seem to be useful. Thanks for watching, and I'll see you next time.